Hey everyone, welcome back to Bugnojutsu. In today's video, we'll be tackling a really interesting problem from LeetCode, number of people aware of a secret. This problem is all about simulating how information spreads, how long people remember it, and when they forget. It combines elements of simulation, dynamic counting, and a little mathematical reasoning. By the end of this video, you'll clearly understand the problem and how to approach it step by step. The story begins on day 1, when one person learns a secret. Now here's how it works. After learning the secret, a person will wait for a certain number of days, called the delay, before they can start sharing it with others. Once that delay is over, they can share it with exactly one new person every single day. But there's a catch: each person will eventually forget the secret after a fixed number of days, known as the forget value. And once they forget, they can never share it again. The task is, given 3 numbers, the total number of days n, the delay before a person can share, and the forget limit after which they forget, we want to calculate how many people still remember the secret at the end of day n. Because the answer can get very large, we return it modulo. Let's walk through an example to really understand this. Suppose n equals 6, delay equals 2, and forget equals 4. On day 1, the first person learns the secret. Only one person knows. On day 2, nothing happens yet because the person is still waiting out the delay. On day 3, the first person starts sharing and tells one new person. Now 2 people know the secret. On day 4, the first person tells another new person, making it 3 people in total. On day 5, the first person forgets the secret, so they drop out, but the second person shares with someone new. That still keeps the count at 3. On day 6, the second and third persons both share, adding 2 more people. By the end of the 6th day, there are exactly 5 people who still remember the secret. This example really highlights the delay in sharing, the continuous spreading, and the forgetting timeline. Now, how do we solve this systematically? Instead of using recursion or complicated backtracking, we simulate day by day. We keep an array that records how many people learn the secret on each day. On day 1, exactly one person learns it. Then, as we move forward, for every person who learned the secret on a particular day, we mark the future days where they will share the secret, starting from their delay day and continuing until they forget. This way, we don't need to track individuals separately. Instead, we track groups of people who learned the secret on the same day. At the end of all the days, we simply add up the number of people who still remember the secret. That means those who learned within the last forget days before day n. This method is very intuitive, feels close to how the problem is described, and avoids the complications of backtracking or memoization. It's just a clean simulation of the spreading process. In this method, for every day we may push updates to future days, so the worst-case time complexity is about n square. However, for the constraints of this problem, this straightforward approach still works well. The space complexity is n, since we only keep one array to track how many people learned the secret on each day. One key insight here is to notice that instead of thinking about each person separately, we can group them by the day they learned the secret. This drastically simplifies the problem. Another insight is that while our simulation is clear, it can be optimized further using prefix sums or sliding window techniques to reduce the time complexity down to n. But even without optimization, the direct simulation gives us a working and intuitive solution, and that's the beauty of approaching problems in a structured way. And that's it for this problem. We walked through the story of how the secret spreads, understood the rules of delay and forgetting, solved an example step by step, and then built a clear solution using a simulation method. If you found this breakdown helpful, don't forget to like the video, subscribe to Bugnojutsu, and hit the bell icon so you don't miss future problem explanations. Thanks for watching, and I'll see you in the next one.